Hi, this is Mrs. Hellier, and this video is to go over the rational review assignment numbers 1 through 6. Alright, so number 1 wants to know when that rational function is undefined. Because that is a fraction, fractions are undefined when the denominator is equal to 0. So we're going to take that denominator, set it equal to 0, and solve for the values of x that would cause that to happen. Since that is a quadratic, we can factor it, the two numbers that multiply to -8 and add to a +2 are -2 and 4. Since there's no number in front of the x squared, I don't have to do grouping. Those numbers will be the ones that end up in parentheses. Set each factor equal to 0 and solve. X will equal 2 and x will equal -4. So when you have either one of those values for x, if you substituted it back into that fraction, your denominator would be 0 and it would cause it to be undefined. So the choice is number 1. Number 2, which expression is equivalent to that? I apologize. I ended up putting some questions on here that I did not intend to do. Didn't realize you hadn't done polynomial division yet. So this does use polynomial division, which means that you don't know how to do it yet. So instead of teaching you the division right now, I am going to teach you the backdoor approach for how you can solve this problem. And that backdoor approach is to pick your favorite number that's greater than 2 and plug it in for x. So my favorite number bigger than 2 is 3, just because it'll keep things smaller. So I'm going to take and plug a 3 in everywhere I see an x. And then after I do that, I'm going to find the value of the numerator by typing it in my calculator. And I get 130 on top. And I'll get a 5 on the bottom. So then when I divide, I get a value of 26. So when I plug my favorite number in, the value of the fraction in the question is 26. So now what I'm going to do is I'm going to plug my 3 into all the x's in the answer choices and see which one gives me a 26. So for choice 1, it's going to be 2 times 3 squared plus 3 plus 5, and I'm going to type that into my calculator. 2 times 3 squared plus 3 plus 5, and I get a 26. That means choice number 1 is my answer. If I were to do that for, say, choice number 3, 2 times 3 squared minus 3 plus 5, that's going to give me a 20. So I didn't get the same 26, and therefore that won't be an answer. So a backdoor approach, anytime you're given an expression in the question and an expression and they're looking for the equivalent one, all you got to do is pick your favorite number bigger than 2, plug it in, and find the one that works out to be the same. Number 3. What's the inverse of this function? Well, f of x is a fancy way of saying y, and the process of taking the inverse is switching the x and the y. So right here is my inverse step. X is equal to y plus 1 over y minus 2. But of course we have to get the y alone so that we can rewrite the function in inverse function notation. So I need to solve this equation for y. And okay, well, I'm going to put that x over 1. That'll create one fraction on either side, and to solve one fraction on either side, cross multiply. So distribute the x, I'll get xy minus 2x, and distribute the 1, and I get y plus 1. I need to get the y's alone, and right now I got 1 on each side, so I'm going to move the 2x to the right, and then I'm going to move the y to the left. Now, I cannot subtract a y from an xy, so for right now I'm just going to write them side by side. And then here's the tricky part. In order to solve for y, I'm only supposed to have one y, and right now I got two of them showing. Well, since there's two terms, y is actually a GCF, and I can factor it out. If I factor out a y, I get an x minus 1. Now I have a single copy of my y, and to get it by itself, I divide by the x minus 1 and get rid of it. So y is equal to 2x plus 1 over x minus 1, and of course that was the inverse, so we can rewrite it in inverse notation. And that would be choice number 2. Now, that was a very lengthy way to find the inverse. Some of you may or may not have figured that out because of the factoring of the y being tricky. So here's a backdoor approach. We know that inverses switch the x and the y. So what I can do is I can go to my y equals in the calculator and type in my original function. Just make sure that the numerator goes in parentheses and the denominator goes in parentheses. So I'm going to do that right now. So I got parentheses x plus 1 end parenthesis divided by parenthesis x minus 2, and I'm going to go get a table. Now I know that taking an inverse switches the x and the y, and I know that only whole number or integer x's show up in my table. So I'm only going to copy down points in my table that come out to be nice numbers. Like I see a -1, 0, I see a 1, -2, and I see a 3 with a 4. So no decimals involved in there anywhere. Now I also know that the inverse switches the x's and the y's. So what I'm going to do now is type in each one of my answer choices and see which one of those produce a 0 with a -1, a -2 with a 1, and a 4 with a 3, because the inverse has to switch the x and the y values. And if you type in choice number 2, you will see that these values appear in the table where they don't for the other choices. So that is a backdoor approach to finding the inverse. Alright, I need to do a little erasing here. Give myself some room. But number 4 says solve for all the values of p. So you have an equation that has fractions in it. And the first thing I notice is there's a minus sign. My mantra is that I hate subtraction, and so should you. So I'm going to change that minus to a plus and distribute the negative to the numerator only of the next fraction. That way I'm not going to misplace my negative. The next thing you need to do when you're solving equations with fractions in them is find a common denominator. So try to factor all the denominators that are there. P minus 5 can't be factored, so I put parentheses around it. Same with p plus 3. Can't factor them, so I package them up in parentheses. My common denominator then is just each different parenthesis. So I have a p minus 5 and a p plus 3. And what you learned to do from there was to make all of your denominators match. So you're looking for a common denominator. So the first fraction has to be multiplied by p plus 3 over p plus 3. Make sure you write it for the numerator and the denominator. That part's really important. Multiply top and bottom by p minus 5, and same thing with the last fraction. Alright, so now we need to do the multiplying, or at least the numerators. So I'm going to distribute the 3p. That gives me 3p squared plus 9p over the common denominator. Plus, distribute my -2, I get -2p plus 10 over my common denominator. And distribute the p. P squared minus 5p all over p plus 3, p minus 5. Now that your denominators are the same, you're just going to drop them. They will all cancel out. And we are going to solve the equation that's left. Now, when I write this down, I'm going to combine my like terms, which are these guys. So I get 3p squared plus 7p plus 10 is equal to p squared minus 5p. This is a quadratic equation. You know several ways to solve a quadratic. Unless you're completing the square, which I don't recommend, you want it set equal to 0. So I'm going to move everything to the left side. That's going to give me 2p squared plus 12p plus 10 equals 0. Now at this point, a lot of you are probably just going to jump to quadratic formula. However, factoring is faster, and when you have a lot of work to do on a problem like this, it's going to be factorable anyway. Now, one thing that you can do is there is a GCF of 2, which we tell you to always pull out. Instead of pulling it out, I'm going to divide it out. So I'm going to divide both sides of my equation by 2, and that's going to knock this down to a p squared plus 6p plus 5, and 0 divided by 2 is still 0. So that just made smaller numbers for me to factor. So now I need to know what numbers multiply to 5 and add to 6. Oh, that's easy, 5 and 1. Remember, you do not have to do grouping if there's not a number touching your squared term. Whatever you choose for your factors automatically goes in. So p plus 5 equals 0, and p plus 1 equals 0. So you get negative 5 and negative 1. Now, you do need to be careful and watch out. When you solve an equation that has fractions in it, you need to check your answers, because if either one of your answers causes a 0 in a denominator, you have to eliminate it, because you can't have undefined fractions. So if I plug a negative 5 into either one of these denominators, do I get a 0? No. So negative 5 is a good answer. If I plug negative 1 into either one of those, do I get a 0? No. So that means both of these answers are good. And on a Regents, if one of those answers caused a 0 and you didn't reject it, of course you're going to lose a point. All right, number 5. Number 5 is tricky. There's a back door, which I'll tell you in a minute. But the concept behind number 5, I'm looking at the answer choices and going, that's just weird stuff. So I'm going to start with adding those two things together. So again, first thing I see is a minus. I hate subtraction, so should you. Distribute the minus to the numerator of the second fraction. So both items change sign. And then I'm going to put the 2 over 1 just to make him feel happy that he's a fraction too. In order to add fractions, you need a common denominator. Well, common denominator is just going to be the x plus 2, so I need to multiply my first fraction by x plus 2 over x plus 2. So when I distribute the 2, I get 2x plus 4 over x plus 2. And then I'm going to add a negative x plus 1 over x plus 2. And now that the denominators are the same, I add the numerators. Well, 2x minus x is x. 4 and 1 make 5 over an x plus 2. And I don't see that answer choice anywhere. Alright, so this is where a simple 2-point problem became a very hard 2-point problem. So here's the concept. In order to add those two fractions together, we had to get a common denominator. Once we had that common denominator, we combined the two fractions by combining the numerators and leaving the denominator the same. Well, under that same concept, that means I should be able to take any fraction and separate it into one or more fractions that all have the same denominators. I'm noticing that every single choice here has a 1, and I know that anything divided by itself makes 1. So I'm going to take this fraction and break it into an x plus 2 over an x plus 2 plus, now what do I need in the numerator to get my x plus 5? Well, I need 3 more. So I have 3 over x plus 2. Now this term becomes a 1, and I have 3 over x plus 2 remaining, which makes the correct answer number 2. That's a lot of work for a 2-point question. Again, I'm not going to demonstrate it here, but I will reiterate. Anytime you have a question that gives you an expression and asks you for an equivalent expression, you can pick your favorite number greater than 2, plug it in for x in your question, and then plug it into each one of your answer choices, and then just pick the one that turns out to be the same number. When you have multiple choice, nobody checks your work. Work the back door if you need to. Okay. Number 6 is another one of those that I should not have put on here because this does involve polynomial division. So, since you don't know how to do that yet, we're going to do the backdoor approach only. So my favorite number is 3. So I'm going to put a 3 in for the x. So in the numerator, I have, let's see, 9 times 3 squared, which is another 9, minus 2 is 79. In the denominator, I get 10, so that comes out to be a 7.9. So now we got to pick whichever answer choice we want, plug in the 3. So 3 times 3 minus 1 over 3 times 3 plus 1. Alright, so all of this is going to be 8 minus, and now I'm going to figure out what my fraction is. So remember, figure out the numbers first. So that's 1 over 10, so that's a 0.1. 8 minus 0.1 is 7.9. So we already found our answer. Okay. Don't try to do that whole expression at once, because unless you're the master of parentheses, this entire denominator would have had to go in parentheses. You mess something up with order of operations, so I suggest you do them separately. Alright, so this is an explanation for the first 6 questions. I will make a second video for numbers 7 through 12.